Alrighty, today we are going to be talking about logistic functions and what they are. Um, Thinking about last week and how we graphed exponential and log functions, um, we know that there's no upper bound, meaning that my y values go on forever and ever and ever and ever and ever. And that's not really the case of application problems where we have population and we have limited space, food, and water, so the amount of growth is pretty limited. Um, One good example about this is how Panther Creek is a capped school, meaning that we have maybe 2,500 students in the building. And if we enroll more people and more people and more people and more people and over enroll, then trailers are going to be overcrowded, classrooms are going to be overcrowded, the lunch line is going to be longer. Maybe we won't have enough food to cover everyone and all of that stuff. Right now we have 33 kids in the classroom, but if we were to add more and more and more people, that 33 might change to 38 or 42 or 45, and we don't want that. So that's why Panther Creek is a very good example of a logistic growth function where we are a little bit capped. In this case, the C value, or the carrying capacity, is that limit before it goes overboard. Our logistic growth function is in the form of C over 1 plus AE to the negative BT, where C is my carrying capacity or limit to growth. So you'll hear either one. So make sure that we know this right here. For example 1, I want to sketch the following functions. So if I wanted to find the y-intercept and horizontal asymptotes, what I'm going to do is plug in 0 and see what happens. So 8 over 1 plus 3 times 0.7 to the 0. Well, 0.7 to the 0 is just 1. So now I'm just left with 8 over 1 plus 3 or 8 over 4. So that means that my y-intercept is at 2. I also know that my carrying capacity is at 8, which means that I have a horizontal asymptote at 8. So my graph should look something like this. It's not that pretty, but it is what it is at this point. You will also notice that it tells you horizontal asymptotes. There are 2. The first one is the carrying capacity, and then the other one will always be y is equal to 0. Okay, in example 2, we have a problem where we have census data for San Diego, and we have P of T is equal to that lovely thing right there. Part A says, what's the population in 1990? Well, 1990 is year 0, so I'm going to plug in 0 for T and see what that is. Well, e to that lovely thing right here is just going to be 1. So all you're going to do is just put this into the calculator and see what that value is. You're going to realize that if you plug in that lovely thing into the calculator, you're going to get 28,002 people. Now, you do want to make sure that you are using an 84 or an 83. Desmos, she is dead. We are reviving the yellow calculators, basically. She's coming back alive. 2B asks for the carrying capacity, which is my C value, aka what is my limit to growth, aka what is the maximum amount of people before we go overboard and we cry because we won't have enough supplies for everyone. In this case, it would be 1,542,444. And then 2C says, in what year will San Diego have 1 million people? This is the fun part because this takes up a page. So we are going to substitute in 1,000 for P of T. Ooh. It's going to get pretty nasty pretty quick. Just like how we had something like 7 over x is equal to 3. If I wanted to solve for x, I could just flip-flop my x and my 3. So that's what I'm doing here for this problem, where I'm just going to switch my 1 plus 54 thing in my million so that I can have the right side be a lovely number. If you were to divide out 1,542,444 by a million, you are going to get 1.542444. I'm going to subtract 1. So now I have 54.082 e to the negative 0.05397t is equal to 0.542444. Now I am going to isolate e because I want to solve for t. So in order to isolate e, I'm going to divide by 54.082. I'm going to leave it like that for now. I have e to negative 0.05397t is equal to 0.542444 over 54.082. The inverse of an e is ln, so we know that ln, e's and ln's will cancel out, so now I'm left with negative 0.05397t is equal to ln of that lovely thing right here. I'm going to divide by negative 0.05397 on both sides. And if you were to do that, you should get our lovely answer of 85.2727. Whew, that was a lot. I know, crazy. And I'm going to round this up to 86 because I feel like with these types of problems, we kind of want to round it to the nearest whole number. And since it is in terms of population, I'm just going to round this up. Now, C, our answer is not 86. It tells us in what year. So we found out T years was 86 years after 1990. So what we're going to do is at 1990 and 86... that's going to give us 2076 as our final answer. I know. Pretty final. Example 3 is very similar to example 2, where you have 10 right here, and you would do the exact same thing. Example 4 is just a plug and chug question. If you're asking for the population in 1850, that's t is equal to 50. Population in 2015, that's t is equal to 215, since t of 0 is 1800. But now, let's look at example 5 and 6, where I want to find the logistic function that satisfy the given conditions. So I have the initial value of 16, a carrying capacity of 128, and then it passes through 532. Well, we know that your function should look like this. Since we already know that the carrying capacity is 128, I'm going to plug that in here. Get 128 over 1 plus 8e to the negative bt. So that works already. The next thing that we are going to do now is find the initial value. That initial value is 0, 16. So I'm going to plug in 16 for y and then 0 for t. Well, if I plug in 0 for t, that e is going to be 1, so I'm only left with 128 over 1 plus a. Once again, I am going to flip-flop the 16 and the 1 plus a so that it makes it easier on us to figure out what that a value is. So now I have 1 plus a is equal to 128 over 16. 128 over 16 is 8. And then if I were to solve for a is 7. So we know now that I have 128 over 1 plus 7 e to the negative bt. Our next goal is to figure out what my b value is, and in order to do that, we are going to use the points that they give us. We're going to use 532. So now, once again, I'm going to do 32 is equal to 128, 1 plus 7e to the negative b times 5, or to the negative 5b. I'm going to switch the 32 and the 1 plus 7e to the negative 5b so that I have a pretty right side. 128 divided by 32 will give us 4. I'm going to subtract 1 on both sides. That's 3. E to the negative 5b is equal to 3/7 after I isolate my e. I'm going to take the ln of both sides. So that I have ln of 3/7 is equal to negative 5b. Then I'm going to divide by negative 5. So this right here is my b value, meaning that my final answer is 128 over 1 plus 7e to the negative ln of 3/7 over 5 times t. On the test, I would just leave b as b, so I am okay if you wrote b as this right here. Remember that you want to be as accurate as possible so that it really truly does pass through 532, and that it really is an initial value of 16, and it really is a carrying capacity of 128. Okay. Number 6, very, very, very similar. So I'm going to speed run through this just like how I speed run the previous example. My carrying capacity is 40, so now I know that my C value is 40. Yippee, hooray, yay. And I know that my initial value is 10, so now I have 10 is equal to 40 over 1 plus a. Because remember, e to the 0 is just 1, so I'm not going to include e. I'm going to flip-flop my 10 and my 1 plus a. 40 over 10 is just 4. So now a is equal to 3. I have 40 over 1 plus 3e to the negative kt, and I want to use 120. That's going to help me find my b value. So now I have 20 is equal to 40 over 1 plus 3e to the negative k times 1, which is just negative k. Going to multiply 1 plus 3e to the negative k and divide by 20. So essentially I'm flip-flopping again. Simplify the 40 and the 20, that's going to give me 2. Subtract 1, divide by 3. Take the ln of both sides, and then divide by negative 1. I accidentally wrote K, but K is essentially the same thing as B. Sorry, guys. So you know that, so you know that your K value slash your B value is negative ln of 1/3. So your final answer is going to be 40 over 1 plus 3e to the negative kt, where B or K is negative ln of 1/3. Answers for 7 and 8 are in the student notes folder. And in addition, if you're given a graph, it's literally the same thing as what we have been doing, except you're given a graph. Hey, this is your carrying capacity. This is your C value. Hey, this is your y-intercept. So 0, 5 is your initial value, and then 210 is your point. So, as a refresher, try to find C, because that's going to be the easiest one to give you. I mean, it's the carrying capacity, so it shouldn't be that hard. Once you find C, find A. To find A, that's where you have to find your initial value, aka your y-intercept. And that shouldn't be hard either, because e to the negative kt is going to be 0, and then you're just left with whatever your carrying capacity is over 1 plus A. Once you find A and once you find C, then that's where you find B, or K in this case for this example, by using the point that they give you, and then find B slash K. Shouldn't be too bad. All right. Make sure that you master this before you move on to Newton's law of cooling, because Newton's law of cooling is going to be very, very similar, meaning that if you don't have this down pat, then Newton's law of cooling might be a little bit difficult. So watch this video first, then head on to Newton's law of cooling.